Hello and welcome to this video. In this video we will study about cycles in graph, in an undirected graph to be specific. So if you are new to the channel, please make sure that you subscribe to the channel and press the bell icon so that you can get notified about more upcoming videos and data structures and algorithms. And if you are watching this video without any background on graph, or if you don't know how graphs work, then I'll recommend that you use the playlist and start visiting from the first program in the graph and then you follow along. Otherwise it will be difficult to directly follow how to detect cycles in a graph. So to create a graph, I have put all the source code in one file only, as compared to 3 files. So to represent a graph, we have a node of a graph which contains vertex and next pointer for adjacency list. For graph, we have num vertices, we have a visited array, and we have adjacency list. The functions which we have in this program are this is not BFS. We have create graph, create node, join, and is cyclic. So the main function creates the graph, joins the vertices, and tests for cycles in the graph. So there are two graphs I have created, and in the first case there will be cycle 0 to 1, 0 to 2, and then 1 to 2, and then 2 from 0. So that is the cycle, and then 3 to 3, that is another cycle. It's a self loop. But in second graph 0 to 1, 1 to 2, there is no cycle. So how the graph is created is, for create node we allocate memory for node, we mark its vertex as v, which is passed as argument v, we mark next pointer to null, and we return the new node. For create graph we allocate memory for graph, we set num vertices, 2 vertices, which is an argument passed here, we allocate for adjacency list, we allocate for visited array, and then we mark all the adjacency lists to null and visited to false. We don't need this entire here, rather we can put it here. So join is basically we join the source and destination in an undirected graph. This is the code. So you should follow earlier slides and programs, you will know how this works. Now for we don't need this, and we don't need this. Now suppose we have a cyclic thing to find. So we iterate on all the vertices, and if visited is false for them, we call util on that node with parent set to 1, -1. Now what happens is, it is essentially a DFS search. So we set visited to true in the util function, and then we iterate over its adjacency list. If the node is not visited, any node in the adjacency list, if the node is not visited, we pass it to util function, and we also pass node as its parent. Okay, so node will be updated here, and in the adjacency list we continue to follow the adjacency list. Now if vertex is not equal to parent, then we return true, and in other cases we return false. Now if this util returns as true, we also return true, otherwise it is false. So essentially the logic is that if we have there are two arrays, reached and visited. So all the nodes we have marked in visited, if the node which we are reaching is already present in visited, then it is a cycle. That is the logic. So when I'm talking about the visited array, you should go and look the previous video what a visited array is. So essentially we maintain a visited array like this. So consider this graph, I'll explain this here. So consider this graph, okay? So how nodes 0's adjacency will look like is, this is node 0's adjacency list. So in the beginning it will be null, and then 1 comes in, and then 2 comes in, and there is no more. Now for node 1, adjacency list would look like, for node 1 it will be 2 arrow null, and for node 2 it will be 3 0 null. Now consider the visited array for all this. Okay, this is our visited array. Initially it is false, 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 and false. 4 nodes, so 4 false. 0 1 2 3 all are false. So in the beginning 0 will be hit. Okay, so 0 is visited, so we mark this true. Then in the DFS or in the logic, what will happen here is it will get I will be 0 and it will be sent to this function util. So this node will be marked true, that is visited 0 is true. Now its adjacency list will be read. Okay, so the first item is 2, so it will send 2 and the parent, because this 2 is false. Okay, so it will send in the util. Now 2 will be marked true. So when you proceed like this, when you will hit the adjacency list for 2, it will see that 2 is already present here. Okay, and from 2 you can go to 0. You see this? So 0 will be already present. So there is a cycle. So that's how this program works. Let's see the test run for this. So we compile this and we run this. So as expected, in the first case graph has a cycle. In the second case graph does not have a cycle. So for example, you can say, let's reduce this graph to one element only. 0 1. Will there be a cycle? No, there should not be a cycle. So it says graph does not have a cycle. So in the essence, you have to draw the adjacency list and iterate over these two functions, and you will know how it works out. So that's it for this video. I'll see you in the next video. I will end this video here. I hope that you find this video useful and informative. Please like the video and share it on social media, and make use of the comment box as much as you want. And let's discuss what more we can do. I'm ending the graph videos here. We will see more videos like Ford-Bellman algorithms and cycles in a directed graph, and many other problems. There are many problems on graph which we will solve later on. And we will, in the next video, I will introduce hashing to you, and we will see more videos on hashing. And after that, I will start coding interview questions with some classic other graph algorithms like red black tree and AVL tree, those kind of stuff, advanced data structures we will see. So, and dynamic programming will also come in picture, which I have not covered. So thanks a lot for watching. Happy programming.